In this quick lesson, we will evaluate the indefinite integral of the square root of 1 plus sine of 2x. Our plan is to turn what is inside the square root into a perfect square, simplify, and then integrate step by step with no skipped steps. Step 1. Use the Pythagorean identity. Sine squared x plus cosine squared x equals 1. We will substitute that 1 into the integrand. So 1 plus sine 2x becomes sine squared x plus cosine squared x plus sine 2x. Step 2. Use the double angle identity. Sine of 2x equals 2 sine x cosine x. Substituting this in gives sine squared plus cosine squared plus 2 sine x cosine x. Step 3. Recognize the perfect square. Sine squared plus cosine squared plus 2 sine x cosine x equals the square of sine x plus cosine x. Therefore, the square root of 1 plus sine 2x is the absolute value of sine x plus cosine x. Step 4. Rewrite the integral using that simplification. The integral becomes the integral of the absolute value of sine x plus cosine x with respect to x. Step 5. Handle the absolute value. We must consider the sign of sine x plus cosine x. To get a clean antiderivative, we work on any interval where sine x plus cosine x is non-negative. So we assume sine x plus cosine x is greater than or equal to 0 on our interval. Then the absolute value drops. We integrate sine x plus cosine x term by term. The antiderivative is negative cosine x plus sine x plus the constant of integration. This is our result on any interval where sine x plus cosine x is non-negative. Important note, if your interval crosses a point where sine x plus cosine x equals 0, you must split the integral at those points.
Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple, one video at a time, only on MyVerse Maths.